Greetings, everyone. We're here back today to go through section 10.6 in our textbook, and this is solving radical equations. So I've got some examples up here that I'll do. I think actually I'm going to switch this over and do the practice problems in the book, not the examples, since I did the examples in class. Alright, so if that's okay with you, that's what I'll go about doing. Similar problems, just different numbers, so it's good to get a variety of numbers in the equations to solve for. Alright, so since I have this one up here, I won't erase that, and I'll just use it. So whenever I have the radical sign here, radical equations, I want to get this by itself, which it already is, and once I do, then I just want to square this, because we know once we square a radical, the answer is going to be what the interior is of the equation. In other words, the square root of 2x minus 3 raised to the second power is just the 2x minus 3 without the radical sign. And if I'm going to square the left side, I also have to square the right side. So there's my, not 9, that's squared 2. Okay, and that's going to give me 81. And then again, so now I can solve for x. This is the easy part. Once I get here, add 3 to both sides. I got 2x equals 84. And then remember, we're going to divide by 2. So therefore x equals 42. Okay, let's see, its partner over here was the square root of 3x minus 2. And this one is equal to 5. Alright, same idea. I'm going to square both sides. This right now. I don't know, better not. And now I know my answer on the left is 3x minus 2. And the answer on the right is 5 squared, which is 25. And now I solve for x. So I'll add 2 to both sides. Gives me 3x, that equals 27. Divide everything by 3. So therefore x equals 9. Okie doke. Next example. Okay, in this next example, practice problem 2, here's my equation, and notice the square root is not isolated. This is sharing this side of the equal sign with the negative 2x, so that means that 2x has got to go. So I know I can just add 2x to both sides, and that'll do the trick for me. So here I've got 9x minus 2, that equals that's the square root of 9x minus 2, that equals 2x. Okay, and now at this point in time I'm going to square both sides. So here's the square root of this. On the right side it's the square of 2x. So I end up with 9x minus 2, that's equal to 4x squared. Okay, this is a quadratic equation now by way of the x squared. And so let me dive up here and rewrite this as 9x minus 2, that equals 4x squared. Alright, so I'm going to bring everything over from the left side over to the right side since the 4x squared is positive. So that means I'm going to subtract 9x and add 2. All at the same time. So that gives me, here's my subtraction of 9x and my addition of 2. So when I do this, it's going to look like 0 equals 4x squared, and what else we got? Minus 9x plus 2. Okay, now we'll solve for x by factoring this. So it looks like I can't factor anything out the traditional way. I've got this 4 here. So this is going to be 4 times 2. Hey, what's wrong with my pen? 4 times 2, which is 8. And then what are my two numbers that'll get me negative 9? Looks like negative 8 times negative 1 is positive 8, and then when I write it up as negative 8 minus 1, that gives me my middle term of negative 9. Okay, so what I want to do now is I'll do the grouping method here for us. So it's going to be 4x squared. Then I'll reintroduce the negative 8 and the negative 1 into this and make it a 4-term polynomial. So this is going to be minus 8x minus 1x, and then what else? Plus 2. Okay, there's my 4-term polynomial. Now I group them and factor away. So left side here, I'm going to take out a 4x, and what's left over is x minus 2. And over the second one, this is minus, and what can I take out of here? I can take out a 1, and then what's left over is x, what's this one going to be? Minus x minus 2. Okay, I'll pull out my common binomial factor of x minus 2, and what's left is 4x minus 1. All this equals 0, of course. So there's where we lie, and now I can see that my solutions are that x is going to equal 2, or x is going to equal 1 divided by 4. And those are my two solutions for that problem. And we always check to see if they work. Okay, here's example 3, or I should say practice problem. No, this is example 3, so let's see, I had that one, then I wanted to do a second one for variety's sake. Variety is a spice of life. Alright, we'll come back and do that one. So for this one, again, the same principles arise. I notice this is a cube root, and I got to get this isolated. So I'm going to subtract 5 from both sides. So over here I have this cube root of x plus 1. My 5 is gone. It subtracts to be 0, and the right side is going to equal negative 2. Alright, since it's a cube root, I'm going to cube both sides of the equation. Cubing the bunch to both sides. Alright, so I know the cube root of this raised to the third power is going to be x plus 1. And that is going to equal, well, the cube root of negative 2. That looks like it's going to be negative 8. And there we go. Now I can just solve for x. How about if I subtract subtract 1 from both sides, so I get negative 9. So x is going to equal negative 9. And that would be fine. That's good. How about this one? How about this one here? I'm going to subtract 2. And how about the cube root of x minus 5? That's going to equal, what's that, 1 minus 2? This is negative 1. Okay, then I'll cube root both sides. And now my left side is going to be the x minus 5. That's equal to negative 1 to the third power is negative 1. How about we add 5? So x equals 4. Okay, and that's that. Okay, here's another example, and this is the ones to be aware of when I have two radical signs on the same side of the equal sign. So as we do these, you will get in touch with the idea that we're going to have to do this twice, because I need to get rid of my radicals on both occasions. So this is what I'm talking about when I do this, and I'm going to start by eliminating one of these two radicals, and I'm going to take this one to get myself rid of. So that means I'm going to subtract this square root of 3x. Okay, I just want to get it and isolate this first term here, and I'll feel better then. So I'm going to subtract this from both sides. This right side is now going to be negative 3x. Okay. Draw my line. And how about I bring down this square root of 3x plus 1. And this is 0, and that's going to equal this right side of 2 minus the square root of 3x. And now I'm back to, it's isolated. Once it's isolated, then I can take this and cube both sides. Did I say cube? Or am I taking the square root here? I'm taking the square root, not the cube. So this is a square job. Okay, so when I take the square of the square root here on the left side, I end up with 3x plus 1. That's going to equal this 2 minus the square root of 3x squared. And that's going to give me, well, I'll multiply this out using the shortcut way, so it's going to be the first term squared, which is 2 to the second. Next is minus the middle term, and the middle term are these three terms multiplied together. So I'm going to do this as 2 times 2, which is 4. And that's my first term squared. and then I'm going to multiply the middle terms. 2 times 2, 4 times negative square root of 3x. So that's going to be negative 4 times the square root of 3x and then I've got to square this last term, which is going to be always positive 3x. So I square the first term, square the last term, and the middle term are these three items multiplied together. Alright, so this is where I'm at. And now I can combine my like terms here, but see, I still have the radical here. This is what I'm talking about when we have two of them. I still got to deal with this radical, which is in the art of isolating this radical now. And I'll do that, well, I'll start that now. This is 2 squared, that's 4, so I'm going to subtract 4 here, and this is 3x, I'll subtract 3x to both sides. So this will be negative 4 here, and my 3x and negative 3x are over here, so these are like terms. Okay, so let's see, where do I go from here? I'm going to subtract this away, and it's going to give me negative 3 equals, and now what is this? This is 0. This is 4 minus 4 is 0. I've got negative 4 times the root of 3x plus and minus 3x over here. That disappears. Okay, let me rewrite this over here. I've got negative 3 that equals negative 4 square root of 3x. Okay, so we're doing fine. At this point now I'm going to divide by negative 4 to isolate this radical. Got that, fine. And now I'm left with the square root of 3x that equals this 3 over 4. And now how about we square both sides? I'll square this one and square this one, the whole thing. So this breaks down to be 3x that equals, let's see, that's 9 over 16, right? So that's 9 over 16. And now simply divide by 3. Okay, so I end up with this x, this part here equals x, and this is going to be 9 over what? 48. 9 over 48. And if I go to simplify that, I know 3 goes into, let's see, let me do it here, 9 over 48. Let's see if this will work. Nope, not 9. Alright, so I got 3 goes into 9 3 times. 3 goes into 48. How many times? 16 times. Okay, and that looks like it's it. That would be it for that problem. Okay, here's one more of the same type, seeing that I feel it's the most difficult. And so this is from the example now. I did this one in class, so I want to repeat it here. And away we go. So I want to isolate one of these radicals. So I'm going to isolate the square root of 2x plus 5, and I'll subtract the square root of 2x. And I do that to both sides. Square root 2x. Okay, so draw my line, and I've got this square root of 2x plus 5. by itself now, and that's going to be equal to 3 minus the square root of 2x. Okay? And now how about we square both sides? Square both sides. And now the square root of 2x plus 5 squared is 2x plus 5. And that's going to be equal to, I got to multiply these two guys out now. Alright? So it is, I'm going to FOIL it this time. 3 minus the square root of 2x times 3 minus the square root of 2x. And I'll FOIL. 3 times 3 is 9. 3 times 3 is 9. Outside is 3 times square root of 2x. So that's negative 3 square root of 2x. Inside is negative 3 square root of 2x. And last is going to be positive 2x. Square root of 2x times the square root of 2x is 2x. And now I can combine these, and at this point in time I will bring it down here. This is supposed to be an x here, right? Outside, yeah, 3, 2, it doesn't look like an x to me real clear, but there it is. Alright, so I end up with what here? 9 minus 6 square root of 2x plus 2x. Okay, as you can see, I've got this radical here again, so that's telling me I have to isolate this and solve for x then. So that means the 9 and the 2 have to go. The 9 and the 2x have to go. So for starters, let's subtract 9 and subtract 2x to both sides. So here I've got minus 9, and I'm subtracting 2x to that 2x. And I end up with, let's see, the left side is negative 4, and that's going to equal negative 6 times the square root of 2x, and plus 2x minus 2x is gone. Okay, so at this point in time, now I'm going to divide both sides by negative 6. And that's going to bring me to, let's see, I'm going to rope this off, and then bring this equation up here so I can continue. So what have I got here? I've got negative 4 over negative 6. I'm going to simplify that to be 2 over 3, which equals my negative 6 divided by negative 6 is 1, and then that's going to just leave me with the square root of 2x. And at this point in time now I'm going to square both sides, and that'll get me the square root of 2x squared is 2x. That equals this number here, which is going to be 4 over 9. And then I'm going to divide both sides by 2. Alright, so we should have that x equals, I'm going to go to the right with this. Let's see, 4/9 divided by 2 is 4 over 18. That simplifies to be 2 over 9. and that's where our solution should be. That's what our solution should be. Alright, that's it for section 10.6. Onward to 10.7. How exciting.